So for 3 and 4, the directions have changed. It says determine whether the polygons with the given vertices are similar. And A, B, C, D, the vertices are listed, and H, J, K, L vertices are listed. Now remember, in order for something to be similar, it has to have congruent corresponding angles, and it has to have sides that are proportional. But another way I can show they're similar is if I can show that there's a mapping that maps one ordered pair to the other. But let's first deal with the angles part of it. I can see slope is 0, undefined, slope is 0, undefined, or slope is 0, undefined, and same thing with this. We got slopes of 0 and undefined. So you're going to have right angles here, which means I'm going to proceed. There's a good chance they're similar. We have to deal with the sides now. Looking at the big figure and counting it over, this side length is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, so is that side because it's going to end up being a parallelogram or rectangle. We already said they were right angles. Dropping this down, we get 1, 2, 3, 4, 5, 6, 7, 8, 9. And likewise, same with here. So it actually ended up being a square. Compare that to the little one. Counting this side over, we go over 1, 2, 3, 4, 5, 6. And drops 1, 2, 3, 4, 5, 6. So, because ABC was listed first, that's the one I'm going to deal with first. That's the big one. So we got sides that are basically in proportion of 9 to 6, 9 to 6, 9 to 6, 9 to 6, or 3 to 2. So if I take an ordered pair from ABCD and multiply it by, and actually here's where it gets a tad confusing because this is bigger, so I have to actually shrink it. So I'd multiply it by the reciprocal 2/3 and then do the same thing for your y coordinate. Will it map ABCD to HJKL? That's the question. And I can't just take 3/2 because I could do 3/2 if I want to map the small one to the big one. That would be the way to use this number we just did. Otherwise, invert it. And so if I take these ordered pair -3, -3, and multiply it by 2/3, you'll notice the 3's cancel, leaves me with -2, -2. So that would essentially be A prime, which notice is H. And so it maps to H. Now if I take the ordered pair for B, which is -3, +6, and multiply it by 2/3, I get -6/3, which is -2, and I get 12/3, which is 4. And that would essentially be B prime, but notice that maps to J. And now we go on, 6 times 2/3 gives me 12/3 or 4. And we're going to get a duplicate number 4 there. So C prime would be 4, 4. And 4, 4 is K. And then D prime 6, -3 times 2/3 gives me 12/3 or 4. And then -6/3 or -2. So that would be D prime, 4, -2. 4, -2 is that. So, yes, they are similar. And they're similar by this dilation ABCD is mapped to HJKL by taking an ordered pair XY and making it 2/3 X, 2/3 Y.